Hello everyone, it's Mike Levin from MikeLevinSEO.com, and I'm out walking my dog, and it's about 6 a.m. on Thursday, August 7th, 2014. And these morning dog walks are probably just about the only daily videos I think I'm going to be able to assure, because I need to walk the dog, I need to compose my thoughts for the day, and I may not get time for desktop screencasts or the whiteboarding that I do. That kind of stuff is going to be more and more reserved for my clients to facilitate the in-person meetings. I am in Manhattan, so it's easy to go to their offices and visit them, but I also like to make a permanent documentary of what I'm doing, the work I'm doing for them, that's accessible only to them. As time goes on, I'll make sterilized versions that refer to my own site that repeats much of the same process. It'll go along with the free and open source SEO tools so that you can see the use of the tools and the process surrounding them. So those tools, I still am going to put the thought work into them because they are necessary. They don't all exist. I created the platform I need for them, and as I describe them, I guess the nature of the platform, the reasons for my decisions become even clearer. So much in data management, in anything having to do with knowledge industries, really, has to do with managing lists. And lists of lists is one of the most popular data structures that can be forced into very rigid structures like relational databases with rows and columns, or spreadsheets with rows and columns. But really what you're talking about is a list of your primary key items, which are the way you look up things. You go, give me the data for this URL, for example, and then the value that comes back, like the contents of the page. And in that way, a very simple list structure, one that has two items on the list, a primary key or a name, call it what you will, and then a value. And so those are key value pairs, very popular. And it's a native data format in Python and JavaScript and a lot of modern high-level languages. And it's also a popular data format in the recent wave of popular databases coined NoSQL. Now, this concept of key value pair databases has been around forever. It was built into one of the early versions of Unix, which was copied and upgraded in a project that has since grown to become the Berkeley DB. So when people talk about Redis and MongoDB and CouchDB, that concept, that NoSQL concept, where name value pairs take front and center stage, has actually been around a lot longer than people give it credit for. But that's just a support of the usefulness of name value pairs. Relational databases bring a lot more performance by kind of deconstructing that a step further and taking what would be the value column and subdividing it into more columns and building more indexes, which are kind of like primary keys, so that lookups are faster against more than just one thing for that record. But I digress. Name value pairs, native in Python, and the underpinnings of a lot of high-performance popular databases. It also happens to be that you can treat and access what appears to you as a native Python, they call it a dictionary item, these name value pairs, treat it as if it were just a regular native Python one, but you're really hitting something like CouchDB or Mongo or Redis in the background, so that it can grow to gargantuan proportions, so that it is big data, essentially. You might have some performance ramifications, but with that you can start to speed up with in-memory caching techniques, but I get far ahead of myself. The point is that whenever I make one of my tools, which I'll be building up in baby steps, I'm going to try and use the URL as the primary key. In those circumstances where I need to look things up by more than just URL, say URL plus the date in order to do like hit counters or something, I will have a compound key that I may even handle on the Python application end, so that the database side doesn't have to know anything about primary keys, but I would use a very fixed digit precursor at the front of the URL, so it would look something like, you know, 080714 http:// and I would include the protocol because pages can be called up in either secure or non-secure format, so you need to differentiate that. It's a different URL because it's calling in through a different port. And then I won't do the whole discussion about query strings, but it's the bane of Google's existence, right? How long was it before they were good at picking up dynamic content? Because if you were laying out the internet as one giant, you know, dictionary object, which you should be able to do because URLs, U stands for unique, you would have one axis with URLs and then one more column on that axis as the value, the contents of the page, maybe shoving in there the headers and any other, you know, data that the user doesn't normally see even when they choose view source, but nonetheless plenty of indexing space. But as soon as you add a query string, Google has a difficult time figuring out how the page could display. URLs were not originally designed to support query strings and were supposed to be able to display without one. That's why all the URL parsers out there, when you ask for just the URL, it doesn't give you the query string. You have to ask for the query string in addition to it. And so the right way for a page to behave is to display without a query string in its proper default behavior. But as we know, some websites use like ID equals, and then the whole website is that file name $ID equals and an incrementing number. And so if Google were not to pay attention to the query string, the whole page would be collapsed down, the whole site would be collapsed down into one page, which probably wouldn't display at that. So I need to resolve that problem just like Google does. And a lot of what Google is doing now with webmaster tools is, and not just webmaster tools, with all the other ways they're looking at a site, is to figure out the query string system on your site so that they know how to spin through all the values that matter and to not spin through the values that don't. Because if they start spinning through values like date on a calendar app, is a spider trap. The crawler would never leave your site if it were not programmed to give up and move on. Okay, so at the heart of a lot of the systems I build are going to be that kind of database, and I'm going to build it up in very tiny baby steps. I need to focus very strongly on client work, so I will not be doing as much coding as I like, but I will probably do things like add the GData library to the Python server, so that when I am holding a dictionary of dictionaries in my hands, I can use the key of the outer dictionary as the first column in a Google spreadsheet, and then deconstruct the rest of the dictionaries and pair them up to the cells that they should be going into, or really I should say that row, because the name in each of the name value pairs belongs to a column title, a header, and then the value is what goes into the cell on that row for that title. So it's a perfect system to sort of flow data into a spreadsheet without being limited to a simple list. And if I program it well, that should just as easily be able to be decoupled from Google Docs. It's going to be very loose coupling and reconnected to industrial databases like Redis or Berkeley DB or even Postgres. There's a lot of following of Postgres for performance and stability's sake, where it can be easily configured to work like a NoSQL database, even though it is a relational database. Oh, and the Python library that lets you do all this is called Shove, which I mentioned in a prior video, and it basically seamlessly swaps out your use of a existing native Python object with the use of anything else on the back end to actually handle the data store. So instead of being in memory on your web server or in a text file, when you move from the dict object to the shelve object, you move from dict to the shove object instead of the shelve object. So instead of into a small text file on your server, on your local server's hard drive, it's going into a database anywhere, even the Amazon S3 database. But in the meanwhile, I do all this work manually, and until I'm sort of hitting my groove with delivering deliverables to clients, all I'm going to be doing is taking note of my processes so that I know how I can start to automate them, which I can hit the ground now automating or semi-automating now that I have my platform to do it on. That's how I differentiate myself. Every once in a while out there in the industry, when I'm working for people, I truly differentiate myself as one of the best in the industry, I believe, because I can bring techniques to this. I can bring a science to this that other people don't. I'm going to give an example, because this is something that used to be a secret weapon. It was how HitTail worked, and how I can make something like that work again now that everyone else is giving up on these techniques. Google stopped passing the referrer variable on a request, so that every time someone visited your page after a Google hit, all the details of the search were also passed to you, including keyword. Google chopped that off now that they switched over to secure format. You can only tell that the visit came from Google and nothing else. Well, you can tell it came from Google. You can tell which Google it came from, whether it's, Google India or Google Sweden. So you can tell which Google. You also have the IP, but you don't have the keyword, but you do have the URL. So you could use such a database as I described, and you could increment a counter every time you received a hit to that page from Google. So you can tell how popular that page is in search, but not necessarily what keywords you're being found on. But you can figure out what keyword it is from a combination of looking at the page itself, figuring out what keyword the page appears to be trying to target, and then you can export your data from Webmaster Tools and try and correlate those pages with those keywords with the pages that are receiving a lot of hits, and maybe perchance knit it all together. But at very least, you have a counter of popularity and from what source in your database, so you can start doing trending. If a page is getting lots of hits from Google, you could do, say, like an area map that shows all your URLs with a vertical being the hit count. So you can kind of see the life of your site in terms of URL popularity in search. And if 2 of your pages are high on that list and all the rest are real low, you know you're not targeting those sub keywords or those sub page, the keywords in the sub pages well, whatever they happen to be. And since I advocate, you know, somewhere from 50 to 150 keywords to target total, deliberate targeting, not circumstantial long tail targeting, that's a different story. But, you know, say you're targeting 100 deliberate word combinations, that's easy to keep in your mind, that's easy to track, that's easy to correlate to URLs, and you should be able to sort of have your finger on the pulse of the site and become at one with the site, your goals, the site's health, and the work that you still have to do. And that's kind of like one of the killer apps for SEO that I plan on developing, that tracking system, amongst various others that all use a very similar underlying data structure. So a baby step project coming up will start to tackle those issues, starting with simple things like installing the Shove and GData client libraries on the Python web server. Dog walk is over. I bent your ears long enough. Share the video if you think morning rambling like this is worth sharing. And hope to talk to you soon. And please don't forget to subscribe.